And I'm going to shut myself.
So, hello everyone. Good morning. This is a presentation of the Center for Future Consciousness, a webinar, because we will be having discussion as well as me presenting. And I'm Tom Lombardo, the director of the Center for Future Consciousness, and the coordinator and the creator of our graphics today is Terry Spataro. Now, to begin today, before I actually get into the webinar, I wanted to spend a couple minutes to comment in memory on our dear friend, Dr. Alan Leslie Combs, who just passed away about a week and a half ago. And Leslie had been a regular participant in the science fiction webinars for the last few years and actively was involved in the future evolution of consciousness webinars. And Leslie, through his life, had been a prolific and influential scholar, writer, um, participant in the study of consciousness, among other things. And in fact, I have up here on the screen three of Leslie's noteworthy books: The Radiance of Being, Synchronicity, and Consciousness Explained Better. The third book there was provoked in response to Daniel Dennett's very well-known book, Consciousness Explained, and Leslie wrote a response to it. Leslie was the founder of the Society for Consciousness Studies, and he was the main editor for the journal that continues to be published through the Society for Consciousness Studies. He was a longtime faculty member at California Institute of Integral Studies. If you'd like to read more about Leslie's life and his accomplishments, Leslie has a Wikipedia page which you can go to and get a little more detail. Um, I wanted to mention Leslie because he was a dear friend of mine, a colleague. In fact, only a couple of months ago, I did an interview with him on consciousness and his thoughts on consciousness, which Terry recorded, and the video of that interview is up on the Center for Future Consciousness YouTube channel under the playlist of consciousness and the future of consciousness. And people really enjoyed the interview. And Leslie had not been in very good health, but I wasn't really aware how serious it was until the last few weeks. And it was rather sudden and a bit of a jolt and a shock that he indeed passed away. Um, I just want to mention one personal memory of Leslie, and I have a lot of different memories, and Leslie and I met on a number of occasions and communicated with each other on email and Zoom for at least the last dozen years. I'm not even sure exactly when we met, but Leslie and I met through Olaf Stapleton, the great science fiction writer, and his novel Star Maker. Leslie has been a longtime devotee of science fiction, and I had published an article, which I believe had been up on Academia EDU, about Stapleton's novel Star Maker. And I met Leslie because Leslie actually wrote to me first and told me of his interest in Olaf Stapleton and Star Maker as well, and that he had really enjoyed the article. And so our friendship really began in a mutual interest in science fiction. But in fact, Olaf Stapleton was a integrative cosmic mind who clearly got into a whole set of related topics dealing with consciousness, such as ethics and mental development and wisdom. And so Leslie and I had a lot to talk about with Ola Stapleton and Star Maker, and then progressively talking more and more about consciousness. So I'm sure everyone who had a chance to meet Leslie online during these Zoom webinars feels sad and feels a sense of fondness and memory of Leslie, who was a really great scholar, really understood his material, was a very kind and sympathetic or empathetic individual, and we'll all miss his presence at the webinars, as well as simply not having the opportunity in any other manner, to, communicate and chat with him. I think um, there was some kind of memorial recently for Leslie, but I'm not sure when it was. I think it was online. But here's remembering Dr. Alan Leslie Combs, dear friend and scholar and a student of consciousness, and for his uh, diverse contributions and his personal presence in the great cosmic adventure of humanity. So that's my little memorial on Leslie. And at this point, I'm going to move into our focus for today, the topic for today in the webinar. But during the chat period, and I'll have a chat period along the way, not chat, a discussion period along the way. If anybody else has any comments they like to make about Leslie, we can talk about it, during the break. So thank you, Leslie. And we all remember you. And hopefully, your work and the ideas that you've attempted to articulate and present to people around the world will continue to have an impact on people around the world. So today, the Future Evolution of Consciousness webinar series, and there's a corresponding book developing in this. This is Module 4, The Evolution of Consciousness, Future Consciousness, and Purposeful Evolution. And I have a quote up here from one of the great thinkers about consciousness in the brain, William Calvin, at least a half a dozen, if not a dozen books that he wrote over a 20, 30-year period. In the quote from William Calvin, which sort of in a lot of ways highlights the discussion today. We are not fallen angels, but risen apes. So I wanted to mention that the book that is being written in conjunction with this webinar series, the chapters that so far in draft form have been produced are up on my Center for Future Consciousness website. And the URL link to that book as it is developing is up on the screen. But Terry will share with everyone the outline of this webinar in the chat room. And so this link that you see up on the screen right now will be in the outline of the webinar. So just wanted to mention that there is a book being written, and the book as it comes out in draft form is up on the Center for Future Consciousness website. And I should also mention that announced through my newsletter, Future Consciousness Insights, and put up on my YouTube channel, Center for Future Consciousness YouTube channel, are all of the previous videos in this series. And there is the URL for my YouTube channel and the consciousness playlist. And they're all up there, including the interview with Leslie and the webinar today. Terry will, in the next week or two, put that one up as well. So if you want to go back and look at the video of today's webinar, you can access it and all previous videos at that link. Now, what I usually do at the beginning of a webinar, whether you attended or not, just refresh your memory if you attended, and if you weren't here for previous videos, this will catch you up to speed a bit on what has been going on. In the opening webinar, I presented the central thesis of this whole webinar series. All of our current challenges and problems in the world are due to weaknesses and failings in consciousness. And the key strategy we should passionately and tenaciously, both those terms, be pursuing for constructively addressing our contemporary difficulties and also for creating a positive future is the purposeful evolution of our consciousness, both at a collective level and at an individual level. So what I'm saying there basically is that, yes, we all agree there are numerous problems in our world today. And my argument is that these numerous problems all reflect deficiencies and weaknesses in our consciousness. And if we purposefully evolve our consciousness, we will have a positive impact on all those difficulties, and we will help to create a better world tomorrow, positive future. And this is something that is an agenda for us at a collective level and at an individual level. And that was the opening thesis from Module 1. Now, when I got to Module 3, here's a summary of what I went over in Module 3. I presented the argument that to understand consciousness, we have to put it or place it into the general context of reality and cosmology in order to understand it. We have to see how consciousness fits into the universe. That's our starting point. So I'm not starting with connecting consciousness with the brain. I'm starting with connecting consciousness, embedding it in the totality of all that exists. That's the way to start. And then I presented the argument that cosmic evolution is the best ontological framework and narrative for understanding reality and consciousness, and is superior to dualist ontologies. And this point, I anticipated there being some debate and controversy around, because basically what I'm saying in here is that a naturalistic evolutionary framework for understanding reality is the most accurate and valid understanding that we presently have of reality, and it is superior to all of the different dualist philosophies and ontologies of two different realms, a higher and a lower realm, that have been articulated throughout history. And so in this webinar, I discussed cosmic evolution. So a question did come up about what was I trying to get at here in terms of consciousness and cosmology. And what I was trying to get at was that to understand the nature of consciousness, whatever consciousness is, we need to place it and understand it within an evolutionary framework. That consciousness is an evolutionary phenomenon, embedded in and reflective of our evolutionary cosmos. And that applies collectively. It applies to consciousness as our species. It applies to each of us individually. We are evolutionarily, we are evolutionary beings, conscious evolutionary beings, existing in a evolutionary cosmology. And so I discussed some very basic principles about evolution, that evolution seems to show this progressive emergent hierarchy of holistic integrative entities and differentiations and laws. And we've observed in the history of the universe and evolution of complexity that is built up through this ongoing hierarchical integration of parts forming bigger wholes that increasingly become more complex and complex and complex. And simultaneously, there is ongoing differentiation in the process of evolution. So the universe has become a more intricate, internally differentiated structure as evolution has moved along. But I also introduced the importance of understanding the significance of entropy and the role of chaos and passing away in evolution. That evolution isn't a smooth, steady ascent, that there's ongoing destruction, there's ongoing dissipation, there's ongoing death, there's passing away, there's chaos in the whole thing. And so the history of evolution has not been a simple, progressive, ongoing process. It has been a very up and down, disruptive process. There's indeterminism, adventure, creativity, novelty in evolution. There's other trajectories besides increasing complexity. There's perhaps increasing intelligence, increasing flexibility, increasing cooperation, increasing creativity. Different ideas have been presented and people attempting to demonstrate that evolution, in fact, is multifaceted. And it isn't just increasing complexity. And I mentioned Kevin Kelly's What Technology Wants as a good source to go look at, a compilation of all the different possible ways in which evolution may be at work within our universe. I mentioned the important idea that evolution seems to involve jumps, beginning with Stephen Jay Gould and Niles Eldredge theory of punctuated equilibria. So instead of like with Darwin, evolution being conceptualized as gradual, it looks like evolution periodically has these dramatic switches, jumps, and increasing complexity where the new gestalts emerge. We see this in the evolution of life. We see this in the evolution of physical matter. And then finally, I mentioned that evolution seems to be accelerating. The key markers in the increasing complexity of the universe seem to be coming closer and closer together in time. And then I presented the idea, which I'm going to spend a good deal of time on today, an idea that we can find in Walter Truett Anderson's Evolution Isn't What It Used to Be, as well as other books, that evolution itself is evolving, which means that the means by which, the processes by which the universe evolves themselves, those processes keep getting more complex themselves. So things are moving faster and faster, and the means by which things are moving faster and faster itself is evolving. Evolution evolves. People have suggested that the history of the evolution of life may be a history of the evolution of evolvability. That is, the capacity to evolve more efficiently, better, increasingly comes into play. And this is going to apply and have relevance to consciousness because I said right at the end last time that to me, the evolution of evolution isn't something as simple as that now we can use technology to facilitate biological evolution, but rather it seems to be the case to me that consciousness entered into the process of evolution insofar as humanity, at the very least, began to purposefully evolve the world in which we exist and purposefully evolve themselves through future consciousness. So we're going to talk about that today in a lot more depth. So that's just a quick review of Module 3. And now I'll introduce the basics of Module 4. Building on that framework, which I just described, of cosmic evolution, I'm going to look at three key um, aspects of human reality, three key features: consciousness, future consciousness, and purposeful evolution. But I'm going to look at them within a historical evolutionary perspective. As a way to understand these three connected features, we're going to look at how they develop, their historical evolution. That's going to be the foundation on which to understand them, and it also provides us with a foundation for understanding our purposeful future evolution of consciousness. So, if we want to understand the future of consciousness, I think it's important to understand the previous evolution of consciousness, the evolution of future consciousness, and purposeful evolution as how they will contribute and be integral in the future evolution of consciousness. And I'm going to discuss the evolution of life and the emergence of those fundamental or basic psychological processes associated with consciousness, foundational processes such as perception, self-awareness, purposeful behavior, learning, anticipation, and emotion. I'm going to look at the prehistoric evolution of humanity and the emergence of various capacities that are empowered by future consciousness. That is, the beginnings of tool making, the construction of artifacts, hunting, social bonding. That is, moving from the evolution of life, I'm going to move into the evolution of humanity. Then I'm going to look at different perspectives on the evolution of human consciousness through this whole process. I'm going to look at the emergence of human civilization and successive civilizational revolutions that were driven by human purposeful evolution. Now, just so to explain something in introduction here, in case that statement doesn't make that much sense, what I'm going to suggest basically is that humans purposefully created human civilization. And they were able to do that because they possess the capacity of future consciousness, which means they guided and directed the evolution of civilization. So whether we moan and groan and complain about human civilization or not, this is something we made, intentionally so. Perhaps not always very wisely, but still intentionally so. And then I'm going to look at the ongoing evolution of future consciousness and paradigms of the future, from ancient mythology and classical times through modernity, contemporary reality, and finally the emergence of science fiction and future studies as more recent developments in future consciousness and the process of this ongoing evolutionary process. So as you could see from that, basically what we're going to have here is a chronological and historical presentation that starts with the evolution of life and the earth, talks about the emergence of perception, proprioception, purposeful behavior, then learning, anticipation, then the prehistoric origins and evolution of humanity, and the Great Awakening, 40,000 BC, the agriculture-urban revolution, and the Anthropocene epoch, and revolutions in human civilization, the evolution of civilization and how it's tied to future consciousness, the evolution of consciousness, the modern evolution of future consciousness, science fiction, and then contemporary theories and paradigms of the future. And I should mention two things here. A lot of this today is a distillation synthesis of material that's in my earlier books, The Evolution of Future Consciousness and Contemporary Futurist Thought. The webinar today is updated and in some ways enriched relative to those two books, but those two books cover lots of this material in a lot more detail. The second thing I just want to mention is that obviously there's an awful lot here to talk about, for me to even describe it and for us to discuss it. So there's a very high probability that this webinar, webinar 4, is really going to be two separate parts. How far we get today, I'm not sure, but I anticipate that we'll have a second webinar dealing with this set of related topics probably in about 2 weeks from now. I'm not sure how far we'll get, but probably we won't get anywhere near to finishing all of this because there's an awful lot of content here, a lot of it to be discussed during the breaks. So we'll see how far we get. So I understand that there's a lot there, and we may need, instead of 2 hours, 4 hours to do this. Now, as I mentioned, the place I'm going to begin is with the evolution of life in the earth. And I just threw up here to start a image of the surface of the earth as it is presently understood 255 million years ago. And if you look at this map, you'll notice that most of the land on the surface of the earth was not split into a lot of separate continents, but was all squashed together or clustered together in two supercontinents, Laurasia, or sometimes in here they have the word Pangaea, and then Gondwana. And what this image illustrates is that fundamentally the earth that we exist in, that we evolved in, is not a stable reality. There are a variety of relative constancies, but only relative constancies, with respect to the makeup and the structure of the earth, but there's a lot of dynamism in it also. The belief that nature, the environment, the earth is some kind of stable, harmonious reality is factually simply not true, but highly misleading. It takes us down the wrong pathway if we're going to understand our future evolution, because we do not exist within a stable, harmonious system. We exist in an evolving, transforming, and highly disruptive ambience. So here's the continents as they existed 255 million years ago, and 255 million years from now, due to continental drift and various other factors, the layout of the Earth is going to look significantly different from the way it even looks now. One interesting little point there, if you look at this map, notice that India is lodged between Africa and Antarctica. And the Himalayan mountains that exist in Central Asia arose and were a consequence of India as a subcontinent slowly drifting across what was then the Paleotethys Ocean and colliding with Asia. And those gigantic mountains would seem so permanent and eternal and magnificent, actually were a consequence in the past of this colossal collision between India butting up against the south of Asia. So our world is not stable. Our world is not harmonious. Our world is filled with flux at its foundation. Now, I up here, and as I go along, I'll do this quite frequently. I'll mention various interesting and relevant books that pertain to the particular topic that I happen to be discussing. And many of you, in fact, are probably familiar with James Lovelock and familiar with his Gaia hypothesis. And his two early books, Gaia and the Ages of Gaia, I have up there on the left. And those are two valuable, I think, resources to look at to understand the evolution of the Earth as a total system and what has happened to the Earth across time. And I'll come back to one significant insight that Lovelock had regarding the ongoing evolutionary history of the Earth. But the first thing to note about the Earth, our home, that which we are embedded within, is that long before the evolution of life took place, the Earth itself was a complex, multifaceted, geometeorological, chemical, intricate system that was undergoing a hierarchical evolution of complexity on its own. That is, when life emerged, it emerged in a complex dynamic system which had a history of its own of evolving. When life came on the scene and began to evolve, it did not evolve through some simple process of adapting to the conditions of the earth. It evolved in interdependency and interaction with the earth. A fundamental point that Lovelock brings up that's important to consider when we think about ourselves in the future is that nature is not sitting over here to the left side with us over here on the right side, and we are, in fact, in some way attempting to adjust, adapt to nature and the earth over here on the other side. Rather, our very history from its primitive beginning in single cell life has involved an active interaction with the system in which we're embedded. So the earth is dynamic, it's rhythmic, and it's disruptive. And we are interacting and influencing this system as life itself has evolved and emerged within it. In fact, it would be appropriate to say that life interpenetrates into the earth and its mechanisms, its chemistry, its physics, its meteorology, its geology, just as much as the earth in its composition has been in various ways assimilated into the makeup of life itself. So life and the earth are not two separate realities, are one integrated reality instead. And life has in various ways influenced what has happened on the earth since it emerged. Our very atmosphere that we breathe today is a creation of life in interaction with the earth and with the sun. But we wouldn't even have this atmosphere that we're breathing, except for the fact that life has made it. So life is an integrative concatenation and differentiation. It involves a mixing together of an interaction with the earth itself. We need to keep that in mind when we think about human futures, in that We are beings that our evolutionary history, our very existence involves manipulating and altering the environment in the earth. We are not beings that can distinguish ourselves, can stand back from nature because we're embedded and impacting nature all the time. That's how we got here. Lovelock spends a good deal of time on this in Gaia, in the Ages of Gaia, and he presents the argument that it's better to see Gaia, the living earth, as a single system of living and non-living aspects in interaction with each other, forming a coherent whole. Now, what happened with the emergence of life was, in fact, the emergence of reproduction, of self-replication via a complex molecular genetic structure that emerged, DNA, which is found in all living forms across the globe. And all of life involves this self-replicating, reproducing complex molecule embedded within our cells, whether it's single cells or multicellular creatures. This is a significant development in evolution because what's happened here now is there is entities in evolution that can reproduce, replicate themselves. All of the different species of life on the earth are all connected together via this common internal genetic structure. And members of distinctive species are distinctive, at least in part, due to the fact that they have distinctive genetic structures in their DNA. So we can distinguish between different species by the particular molecular configurations of their DNA. But there's something else significant about this emergent new structure and new process, which is that even though...
Tom, are we stuck?
No. What was that? Oh, okay. It was a little pop into the flow of things. Even though DNA self-replicates, it does not self-replicate with 100% fidelity. The replication process is continually producing variations on the genetic structure that's undergoing self-replication. Now, Darwin and other biologists have considered this as possibly simply random variation in genetic replication, which is important, but treat it as simply noise in the system. Yet, this very noise in the system is critical because given the fact that self-replication is not absolutely 100% perfect, offspring of a particular parent will vary due to their slight variations in genetic structure. And given variability in the offspring, the process of natural selection kicks in insofar as different variations of the same genetic line will compete against each other for the opportunity to reproduce. So there's nothing purposeful in this, but notice this is sort of like a process of trial and error. Here's a blueprint, let's reproduce it throw in some variations on it, and see which ones work better. And by doing that, Darwin explained a good deal of the ongoing evolution of life as due to natural selection of variations in offspring. This accelerates and complexifies the whole process of evolution. So instead of having simple chemical molecular evolution or geological evolution, now we have evolution that is speeded up through this ongoing process of natural selection of a complex self-replicating chemical molecule. And so this to me seems as a prime example of a jump in the evolutionary process above and beyond chemical evolution. Now, in case, just to go back to this point, in case it seems strange me talking about chemical evolution before life, in fact, there was an incredible amount of chemical evolution going on the Earth, going on in the cosmos prior to the emergence of life. And chemical evolution, I mean that atoms forming into compounds, forming into complex molecules in an incredible variety of different forms was an ongoing process occurring probably across the universe before the emergence of life on the earth. But what happens with life is we have a mechanism of self-replication of the chemicals being able to reproduce themselves, and in reproducing themselves, create ranges of variation, which then gets selected in terms of which ones stand a greater chance of surviving to produce offspring of that particular genetic variation. So that's a very quick overview of the beginnings. Complexity, self-replicating complexity, emerging in the context of a dynamic and complex ambient system, the Earth, interacting with it, influencing it, and over a period of time, evolving increasingly so in its own complexity. So, given the emergence of life, let's take another step. How are we going to begin to connect the evolution of consciousness into this? And two books I have up there that are worth reading on the topics I'm going to talk about today, and not today, on this slide, are Stephen Jay Gould's Wonderful Life, which is a discussion of life on the Earth approximately 500 million years ago, and Antonio Damasio, a neurophysiologist, and the significance of feeling and emotion in the foundations or beginnings of consciousness, the feeling of what happens. But I also have up there a picture of one of my favorite prehistoric animals, which a lot of you may recognize. It's a trilobite or a trilobite. And trilobites were multicellular living creatures that flourished. In fact, were one of the dominant forms of animal life, many, many different species of them, from around 550 million years ago to I think around 200, 250 million years ago, where they went extinct. And I should just note as we get into this slide that trilobites had moving limbs, a whole series of them on each side. They had compound eyes. They had feeling antennas. They had a nerve cord a spinal cord that ran down the center of their body with a ganglion swelling on the upper end up toward the head, which is the beginnings of the evolution of the animal brain. But it was a swelling up there on the end. And they had the capacity to move about, to search out for food, to avoid predators, to see, probably smell, and hear the world around them. And they lived underwater, obviously, and they flourished for 300 million years. Now, my educated intuition or judgment, for a variety of reasons, is that the trilobite was conscious. Conscious at its level of mentality and existence, but it was conscious. It was perceptually conscious. It saw and heard and smelled the world around it. It had a sense of its own body and its position and its internal operations. It was a homeostatic, proprioceptive living form. It felt itself and it showed purposeful behavior. It went after food and avoided predators and did various things to secure its own survival and safety. So I'm going to see consciousness at least running back to creatures like the trilobite a 500 million years ago. But I have to say that when we do look at current single-celled life forms and plants, even at one cell, an individual single-cell life form is a complex and integrated whole. It has many, many different parts, many different processes going on, many different internal chemical metabolic reactions. It demonstrates homeostasis. It has mechanisms for keeping itself stable, which involves self-monitoring, chemical self-monitoring and adjustment. And single-cell life forms that exist today, there's lots of evidence that they show discriminatory, they could discriminate differences in stimuli around them, goal-directed behavior in response to environmental patterns, to changes in light, changes in chemical concentration. And you could legitimately argue that since it's showing these qualities at the level of one single cell, that perhaps single cell life forms, in some primitive sense, are conscious. And these single cell life forms began to, when they first emerged in the history of life on the earth 4 billion years ago, 3 to 4 billion years ago, they began to transform, and I'm not saying intentionally or purposefully on a collective level, they began to transform the earth. Single cell life forms are the architects of our atmosphere. So you could plausibly argue that because single cell life forms show discriminatory goal-directed behavior, and as I'll mention in a little bit, they also seem to be able to learn. And they show homeostasis involving self-monitoring. Maybe you could say they're conscious. But clearly, when we come to multicellular life forms, which emerged around a 500 million years ago, and this was an evolutionary jump, by the way, from single cell life forms to colonies of single cell life forms integrating into multicellular life forms. And we see this with the multicellular life forms, the differentiation in their bodies of sensory systems, muscular systems, and nervous systems. These are distinctive structural differentiations, which we possess too, and the trilobite possessed. The sensory systems being involved in perception, sensitivity to the environment around them, the muscular system being involved in bodily motion, in fact, goal-directed bodily motion, and the nervous system integrating the sensory and muscular systems, as well as integrating all of the other processes going on in the body. When these show up in animals, these differentiated and integrated at the same time structures definitely demonstrate a jump, evolutionary jump, in both the capacities of perception, discrimination, awareness of the world, and a jump in coordinated intentional behavior. And as I mentioned with the trilobites, they had an enlarged frontal ganglia, the beginnings of the evolution of the brain, which received input from sense organs such as their eyes and antenna. They had an extended nervous system with the enlargement in the head region, and they had compound eyes and antennae as sense organs, and they had muscles in their body. And you can tell all of these things by looking at trilobite fossils and seeing how the various structures are laid out in the fossils. But as I mentioned, I clearly would think, non-controversially, and we'll get into that a little more, that even if you would say that the single cell life form isn't conscious, I would definitely say that creatures like trilobites were. And obviously, then everything that was multicellular afterwards, because they had these complex integrative structures in their bodies, which allowed them to perceive the world in great richness and detail and regularities, interact with the world, and coordinate together their perceptions with their behaviors. So we can have discussions about, when did consciousness emerge? But clearly in this case, it seems to me that by the time you get to multicellular creatures, you have sensory consciousness, which is both proprioceptual and perceptual, and you have behavioral consciousness. You have a experience of intentional, purposeful behavior. And I highlight out here the issue of proprioception, because that's going to be an important thing to consider when we think about the evolution now and into the future of self-consciousness. Proprioception, as a general term, means sensitivity to one's own states. And they could be one's feelings of the body, of one's equilibrium, of gurgles in the stomach, of itchiness on the skin, or of my position relative to other things around me, or where my hand or my nose is relative to the rest of my body. That is, proprioception can be thought of as a general awareness or sensitivity to begin with of the biological body to its own state and its own position and relationship within the environment. And it seems to me that this is the foundation of what we call self-awareness. When I get to the point of thinking, who am I and what is my purpose in life? I would suggest that those kinds of self-aware questions and that self-aware capacity begins in the fundamental experience, consciousness of here I am in the world and the tiger is coming right after me, or the shark, or whatever, and I got to get away. Awareness of oneself as a body. And Antonio Damasio had up on his slide, on the slide before, makes a big point of this fundamental foundation of bodily sensation. And this is going to include sensations and sensitivity to my body relative to the world as being at the foundation of consciousness. That consciousness starts in Damasio's mind as a feeling of what is happening. And in particular, with proprioception, a feeling of what is happening to me. This is before words, before thoughts, before higher cognition, but simply as conscious feelings, which eventually evolve further into conscious emotions. But to begin with, simply feelings of the body. So I am not arguing for a materialist view of consciousness, that consciousness is nothing but body and brain functions. But I am saying that consciousness seems to be intimately connected at a foundational level with certain fundamental capacities in life, such as perception and goal-directed behavior, and that there are differentiated structures that emerge in animal bodies that are able to support and execute those psychological capacities. So, whether you believe in panpsychism, that everything in the universe is conscious, or you believe that you have to have certain necessary key virtue features in biobehavioral complexity before you get consciousness, I do think that when we look back in the history of life, we can determine and see that there are certain structures connected with certain fundamental conscious processes that definitely are there by the time you get to animals. And so, definitely by that point, I would say we have consciousness as well. But as I mentioned at the beginning, single cell life forms seem to show certain characteristics that are psychological and fundamental, that one might say they're conscious too. And if you, I put in parentheses, they're plants, because in fact, there's plenty of indications that plants, when you speed up the film and show their growth through time, seem to show something like awareness of directions of light, of nutrients, and they grow in what look like purposeful directions. So the foundations of consciousness I see as beginning in perception, proprioception, purposeful behavior. And no, purposeful behavior means that animals didn't simply run away from things or go after things to eat them. They also did various things that involved effects upon the environment that they were living in. So I would say that the foundation of consciousness, and this reinforces what I said from the previous webinar, are not transcendent, but are a set of capacities embedded within and involving physical, environmental, bodily dimensions, and involving an interactive engagement with the environment around them. So consciousness, to me, at this level, seems to emerge as something which is connected with our engagement and interaction with the environment as living forms that we're in. Now, right now, I see that it's 10 after 11. And I know I've only gone through a little bit so far, but I think maybe it's time we take a little bit of a break. And as I said, I'm not going to finish all of this today, but we could take a 5 minute break. And if we have comments, we can spend 5 or 10 minutes perhaps talking about them. So I'm going to stop sharing on this slide.
Tom, I have a question about that last sentence on that slide.
Okay, quick. I got to the next one. Go ahead.
Yeah, and if you could go back to that last slide, it's the very last sentence that has to do with transcendence. And so I'm just wondering if you could flesh out a little bit more about where you see the line between the evolution of consciousness as an emergent property, as opposed to what your concept of transcendence is in terms of how humans across the world view their consciousness as a property of transcendence.
Okay, I just had to get back to the last slide.
Yeah.
Okay. Okay, what I mean
Very,
by what I mean by that last sentence,
mhm.
that the beginnings of consciousness lie within the interactive, engaging capacities of life forms with their environment, that the source of consciousness is not from some realm beyond or above nature, but rather is within nature, and in particular within the interaction and embeddedness of life vis-a-vis the environment and their own bodies. So the term transcendent there is in reference to the notion that there is some beyond nature, above nature source or originating point of consciousness. Rather, I'm saying that consciousness emerges within the interactive relationship of life with its environment and its own bodies. Okay, I think that's pretty clear, but we can talk about it a little more at the end. But that's what I meant,
Okay.
Paula, by that. Okay, yeah, all
Yeah,
right,
no, and I'm not disputing you. I understood that you were referring to it not being a property of, say, some Deus ex machina, zapping us with
yeah,
this conscious property.
yeah.
I'm curious, and I'm putting this as a provocation for you to think about how humans across the world think of transcendence as being integrally tied to their evolving consciousness as humans. So just something to sort of park somewhere and then come back to.
Okay, all right. And Paula, write that down in the chat box, and then we can come back to it so that you remind me of it. Okay, what you just said. Okay, so we'll continue now. But thank you. Yeah. All right, go to the next one. The emergence of learning, anticipation, motivation, and emotion. And I'm going to bring in these psychological processes as additional fundamental dimensions of consciousness and discuss them in the context of the evolution of life past the point of the trilobites in the Cambrian period. And up here I have imagery from two very distinctive periods within our Earth history and the evolution of life. On top, I have some characteristic dinosaurs, Spinosaurus, Stegosaurus, Triceratops, and down below, during the age of the great mammals and the giant birds, I have some mastodons, or woolly mammoths, a giant sloth. The largest mammal that ever walked the surface of the earth, for which we have fossils, is the third creature, which I forgot the name of, but is related to rhinoceros, and then we have a giant predatory bird there. Uh, in the interest of getting a little more exacting here, I decided to go look for a picture as best as we can understand it of the brain of a Tyrannosaurus. And so we're going back about 65 million years here. And note that if you could see it, the brain of a Tyrannosaurus was rather tiny in relationship to the size of its head. It's that little dark spot on the top of the head. But when you get up close to the brain of a Tyrannosaurus, you find a very distinctive and enlarged olfactory bulb, which is connected with smell, a distinctive cerebrum, and then behind it, a distinctive optic lobe, which evolves into our occipital lobes, a rather large cerebellum proportionately, which is involved in coordination of behavior and other processes. And then, in fact, the semicircular canals in the brainstem and cranial nerves. The semicircular canals are involved in balance. Now, I bring this up because number one, the Tyrannosaurus brain is structurally, in terms of its basic divisions, similar to a human brain. It's simply that in human brains, we have a very enlarged cerebrum, for one thing, and the alignment of the structures kind of switches around where the cerebellum and the semicircular canals become more toward the bottom of the whole thing. But lots of us have seen pictures of the tripartite brain, of the triune brain, that the brain has been described as having as its core a reptile brain, and then surrounding that a mammal brain, and then surrounding that a primate brain. This reconstruction of the Tyrannosaurus brain, who was a possibly warm-blooded reptile-like creature, a dinosaur, has those same basic structures already. It's simply that certain areas here swelled up and other areas shrank down more as you move up through the last 65 million years. So the basic structural divisions in the brain of us were there in the Tyrannosaurus. It wasn't like other layers got put on top of this, on what you see in the Tyrannosaurus, but rather different parts of it grew in size and interconnections and complexity. But I just thought it'd be interesting, and I've always enjoyed looking into dinosaurs, and I wanted to go see what we did know about the structure of the brain of a Tyrannosaurus, and there's an image of it right there. Now, three books I'm going to talk about and cite here are Jeff Hawkins on Intelligence, Richard Young's Future Minds, and Darwin's classic, The Expression of Emotion in Man and Animals. Now, I have an asterisk by this. Genetics are fixed in a single generation. That is, I'm born with certain genes and they don't change throughout my lifetime. As it turns out, you got to qualify that a bit because, in fact, different genes may become activated due to various environmental events. So it's not like our genetic structure is entirely fixed in a certain set of functions throughout our life, but it is relatively fixed. And animals with nervous systems, multicellular animals, show relative flexibility in their behavior. Now, what that means is that even if I were born with a certain genetic structure, which is a central factor in determining my capacities and my anatomy, animals show flexibility in their behavior. And in particular, they show the capacity to learn. Now, I should also mention, because I got another asterisk there, none of these are absolutes. Now, Bacteria seem to be able to share, exchange their genetic material in response to changes in the environment. So bacteria, even though they have a genetic structure, are not totally inflexible because they can share parts of their genetic structure with each other. Now, humans in a lifetime, we don't do that. We share a genetic structure with mates when we couple together and reproduce, but we don't normally, in any notable fashion, share our genes with each other while we're alive. So genetics seems to constrain to a degree the behavior and the abilities of creatures, including animals. But when we bring in the capacity for learning, we find this increased variability that goes beyond simply what I've inherited. So at some point, and the evidence here seems to be even that single cell animals demonstrate some element of learning. But definitely when we get to multicellular animals, even though they have a fixed genetics, they can modify their behavior and they seem to be able to learn and develop new behaviors and new discriminations based upon their interactions with the environment. So this, in my mind, is another jump in consciousness and in evolution, because now we have flexible consciousness. We have consciousness that can assimilate into it experiences of its encounters with the world. It learns. And in fact, we're all familiar with the classic conditioning experiments of Pavlov, fundamental classical conditioning as being a basic type of learning. But the thing to keep in mind about either classical conditioning as studied by Pavlov or operant conditioning as studied by Skinner and Thorndike is that this simple kind of conditioning learning demonstrates the acquisition of knowledge of the past. That is, the dog has learned that when the bell goes off, food is going to follow. It has learned something about the past. It carries that with it. The rat learning the maze has knowledge of the maze, having gone down it before. So it has incorporated an understanding, at least in terms of its behavior, of something it encountered in its past. So to me, this seems to be the beginnings of our evolving consciousness of the past, and not just simply consciousness of the present, but a consciousness of our own past. And that's demonstrated through learning. But when we come to the question of, well, what is the value and function of learning? If we look at back to Pavlov's dog and classical conditioning, or the rat in the Skinner box, the learning serves the function of provoking anticipation of what is to come. Based on what I've experienced before, I am demonstrating that I'm anticipating, expecting that same thing to happen again in the immediate future. Hawkins, in his book on intelligence, and Yak in his book on future minds, both of them present the argument that intelligence fundamentally and brain functioning fundamentally is the capacity to anticipate and anticipate with competence. That is, once we start to get an increasing knowledge, even if it's in a fundamental form of the past, we ipso facto start to develop a set of anticipations of what is to come, at least in the immediate future. So learning has its a evolutionary benefit that it provides a foundation for anticipating what's going to come in the future. So a key feature of our evolving consciousness is that consciousness, once we get learning into the picture here, seems to bring with it this expanded awareness of past and future, at least in some limited level. But there, animals are not simply, insofar as animals learn, creatures of the immediate present, but they have a sense of both their past and of their future, at least in certain concrete, limited ways. Now, in fact, if we look at the way the brain and the nervous system involved in perception and behavior are organized, the brain nervous system doesn't simply receive inputs along sensory channels and then respond to them. The brain is an active anticipator, an explorer. When we see or listen, we explore, we look, we are anticipating what is to come. When we look at the structure of the brain is loops of activity where the brain is continuously adjusting and modifying what's coming in as a consequence of impulses it's sending down. The brain is anticipatory and it's very functioning. I don't just simply receive from the outside. I perceive what's going on in the outside and anticipation and exploration of it. That is, I am an active, self-initiating being who engages with the world and has expectations about the world as I'm engaging with it. So this phenomena, as I've just said, to me seems to be the foundations of what later emerges in us of historical consciousness and future consciousness, beginning with the simple factor that through learning, I acquire the capacity to anticipate the future, even if it's very concrete and relatively immediate futures. Now, the other thing that emerges early on in animals, to me, and this is something we could discuss at length, is the phenomena of experiencing pleasure and pain, of having fundamental emotions such as fear and revulsion and love and caring and motivational desires such as hunger and the need for safety. And so these fundamental desires are connected, these motivational dimensions are connected with our purposeful and goal-directed behavior. Insofar as we're motivated, insofar as we act to produce certain ends in the future based on our motivation, this is a form of future consciousness implicit in goal-directed motivated behavior. So just in summary, prehistoric animals seems to demonstrate perception and proprioception, learning and anticipation, feeling and emotion, and purposeful goal-directed behavior. All of those contribute into the ongoing evolution of consciousness. Now, if I recall correctly, I put something up here that I wanted to just show you. Okay, this is a duck-billed dinosaur, Maiasaura, which means mother, good mother. Yes, good mother. And Maiasaura lived about 65 million years ago, about the same time as Tyrannosaurus Rex. And there's lot of fossil evidence to indicate that Maiasaura clustered into groups, collective groups, protective groups, and laid its eggs together and then nurtured and cared for its babies after they were born. So, as far back as 65 million years, we see maternal care being demonstrated in these prehistoric creatures as a form of fundamental animal motivation to care for my young, to be motivated to protect my young. Aside from more primitive motives, desires like hunger or safety, here we find maternal care as obviously a capacity that's emerging with dinosaurs 65 million years ago. And clearly today we see an awful lot of this in many, many different species. But this one, this motivation, this fundamental feature of consciousness goes back to the dinosaurs. Now we're going to jump forward again. Now I threw up here a bunch of provocative diagrams, which will be helpful in the following discussion. Now, there's plenty of different images that have been produced, graphs that have been produced regarding the evolution of hominids into humans over the last, this one runs back 12 million years. With the split between gorillas and chimps, hominids occurring around 9 million years ago, the fossil evidence indicating a split between the hominids and the chimps and the bonobos around 7 million years ago. And then based on a series of fossil skulls, discovered the evolution of hominids, and hominids meaning erect bipedal apes, us, beginning with Ardipithecus, then various species of Australopithecus, then about 2 million years ago, Homo habilis, then Homo erectus about 1 million years ago, and then, excuse me, Homo heidelbergensis, about 500,000 years ago, and then Neanderthals and Homo sapiens. And that's representative of our current understanding of the evolution of humans out of the primate ape line into the hominid line. On the right side, you could see some reconstructed images of a Australopithecus, a Homo habilis, then a Homo erectus, then a Homo neanderthalensis, Homo Neanderthals, and then Homo sapiens. And across the board on the right side, there has been a steady increase in the relative size of the brain, except to note that the Neanderthals, at least some fossils of Neanderthals, had brains at least as big as Homo sapiens. And it's also important to note here that although the Homo Neanderthals and Homo sapiens seem to have evolved off of Homo erectus, the Neanderthals and the Homo sapiens were cousins, both descendant off of Homo heidelbergensis and Homo erectus. Although we clearly seem to have interbred with the Homo Neanderthals. Now, some other images I have up here that are interesting, provocative. On the bottom side, there are some tools made by Australopithecus 2 million years ago. So as soon as we get to that point in our evolution, we're making tools and we're using them for reasons of making other tools, skinning animals, and whatever else we use them for, and digging. So our ancestors were tool makers back at least 2 million years ago. The next one shows the migration of Homo sapiens out of Africa, beginning roughly 100 to 120 million years ago, and then spreading up into Europe, across Asia, down into Australia, and eventually across Asia into North America. The orange area that's colored in there, extending from Central Africa across Asia, that's the extent of migration of Homo erectus. So before Homo sapiens, modern Homo sapiens, evolved in Africa, Homo erectus had came out of Africa a million years ago, probably around there, and migrated all the way over to China. And Homo erectus apparently did not go extinct until 100 to 200,000 years ago. But we were not the first species that became a global migratory creature. And then the two final images I have up there, which I think are interesting, are first of all a sculpture of the bust of a female made out of mastodon tusk. And that bust is dated at 25,000 BC. So, at least by that point, if not earlier, we had become sculptors and artistically pretty good at it. The rhinoceros are also interesting, the cave painting on the right, because that one's 35,000 years BC. But secondly, the top part of the image, where you see the rhinoceros with multiple curving tusks, interpretations there, as well as other similar drawings, are that the humans who drew that were attempting to depict in the image motion, movement, the rhinoceros's head moving and showing the multiple tusks. So those diagrams help to provide some graphic, big picture images and important details on the evolution of humans over the last 10 million years. The hominids, the erect ones, don't appear till probably around 6 million, if not 5 million years ago. And finally, this is a very powerful and gripping reconstructive image of a Neanderthal woman. And this is from National Geographic 2008. But in spite of the fact that we had this long-term stereotype of seeing the Neanderthals as ape-like and bestial, here's a very human-like face reconstructed from a skull of a female Neanderthal. And I think it puts some flesh and personality and vividness into our prehistoric cousins when we look at this kind of reconstruction of what a Neanderthal actually would have looked like. And other people have attempted to do similar kinds of art reconstructive efforts. Again, if we dressed her up and gave her some makeup and threw her out on the street, we might have trouble distinguishing her from Homo sapien women. And as I mentioned earlier, there's clear evidence that all European and Asian humans, not African humans, but European Asian humans, all of us have Neanderthal genes in us, that our Homo sapien ancestors interbred quite a bit with the Neanderthals. And some of you have friends that you probably think look a little bit like Neanderthals, at least the caricature we have of Neanderthals with the big, thick brows. There's, of course, ongoing discussion about why the Neanderthals went extinct, but there's a sense in which, hey, maybe they didn't quite go extinct. We bred with them, and now we have, and our descendants here for a large portion of the population, a significant amount of Neanderthal blood in us. Okay, I have up here a number of interesting books on the evolution of humans that I found really educational, fascinating. Johansson's story of the discovery of Lucy, um, the Australopithecus that is, what, 3 million years old, that he found in Africa. Um, Alice Roberts' Evolution, the Human History, if you like, a very interesting, comprehensive book with lots of pictures. Um, on the right side, going down, a book on prehistoric art, which is psychologically very fascinating about our early art, not just paintings, but sculpturing, focusing not just simply on Europe, but through other parts of the world as well, which gives us an enriched sense of the cognitive capacities and psychological mentality of humans 40, 50, 60,000 years ago. At a fictional level, a very compelling and realistic depiction of our prehistoric ancestors from Homo erectus and Neanderthals to early humans. I would highly recommend Stephen Baxter's Evolution. It's a first person narrative of the evolution of humans, told through the eyes of a set of fictional human ancestors running all the way back into the distant past with the demise of the dinosaurs. And then two of William Calvin's books on the evolution and history of humans and human consciousness, the Cerebral Symphony and A Brain for All Seasons. The Cerebral Symphony gets into the evolution of the frontal cortex and future consciousness and why that became enhanced, emerged further with humans, and A Brain for All Seasons, discussing how climate change has periodically kicked humans into further evolution, our human ancestors, into further evolutionary developments. So, contrary to creationism, the fossil record and our anatomical and physiological continuity with the rest of the animal kingdom shows that we're connected with animals, that humans, in no sense and fundamental senses, are unique within the animal kingdom. All of the basic structures, anatomical structures that are us, we find in animals, same chemistry, same basic DNA, and we're continuous with them. And our evolutionary history, as revealed through what we've dug up so far, shows a divergence of the primates and then the apes and then the hominids becoming bipedal that you can map out in the fossil evidence running back 10, 20 million years. Now, this is a controversial area of study, and new discoveries are continually appearing, and new species in the hominid bramble bush are appearing at different times. Where we've become aware of the Devoceans, correct, who were contemporaries with the Neanderthals and Homo sapiens, of the tiny humans that lived down in Indonesia. The evolutionary history of our ancestors shows both punctuated equilibria, these jumps, in particular in brain size and in body posture, and we got bigger through these different species. But it shows multiple lines of Australopithecus. It's a bramble bush of interbreeding. It's often connected with environmental transformations. And our history is multiple extinctions and dead ends. Our evolutionary history is not some smooth sailing, increasing complexity on one simple line of evolution. It's continuously branching, and there's lots of dead ends in it. So it's not like we're on some inexorable walk or development forward. There's been lots of dead ends in our history. But if we trace out some of the important links along the way, with Australopithecus, of which I mentioned there were multiple species, we find the creation and use of various tools. And tools are a significant form of future consciousness because making a tool means I take something from my natural environment and in various ways shape it to be used for some intended end at some future point in time. And in fact, we started to make tools for making tools back 2 million years ago. And it served, as I mentioned, they serve various functions. With Homo habilis, who also made tools, we see a jump in brain size, and we see probably significant evidence for cooperation among members of the species. Now, generally speaking, and maybe we could, excuse me, I'll take that back. Okay, I'll start that over again because I was going to say something that I realized it was wrong. Something our species began to demonstrate from some point very early on is that when they went out to either hunt or gather food, they didn't eat it right there on the spot, but they brought it back to the group, to the tribe, to share among the members of the group. That is, they didn't go in for immediate reinforcement and just living in the here and now. They actually showed this future consciousness of, I'm going to bring this back and give some to my family and my friends in the group. So they may have killed the big animal someplace, but then they brought it back and shared it. Homo erectus clearly shows that. In fact, Homo erectus shows lots of significant emergent properties. And Homo erectus emerged about 2 million years ago. It seems to be the first of our ancestors who learned how to control fire, who also developed cooking, who adorned their bodies in makeup, would seem to indicate some kind of social status within the groups, who engaged in committed male-female bonding, and collectively were the first hominid species in mass to migrate out of Africa. And I also forgot to mention there that they definitely engaged in food sharing. When we get to Homo heidelbergensis, we especially see a jump in the size, relative size of the frontal cortex. And as I mentioned, Homo heidelbergensis, which emerged in Africa, then was split, at least one split, probably others, into Homo sapiens, which emerged roughly 250,000 years ago, and Neanderthals that emerged 400 plus thousand years ago. And Neanderthals came up and settled Europe and adapted well to the cold climate of Ice Age Europe and stayed there for 400,000 years and probably bred with Homo sapiens and perhaps competed with them for the same resources. So we have this ongoing multi-step history of our ancestors. And then we come to a significant event in our evolution. Some group of Homo sapiens migrated out of Africa, perhaps around 100,000 years ago, bringing with them a whole assortment of cultural and technological evolutions, developments. Whether they emerged rather suddenly whether they emerge piecemeal across Europe, across Africa, they brought this advanced culture with them up into Europe. And also, it spread down into at least as far as Australia. So around 40,000 BC, and we see it in Europe and we see it in Asia, we see this incredible, relatively sudden proliferation of cave paintings, of abstract drawings, of trading across large distances, of various kinds of art. And I'll come back to this, of mythograms. And we see after that point an acceleration in cultural evolution. And so every 5 to 10,000 years, you'll see a big difference occurring. Somewhere in there, language emerges, but somewhere in there, clearly, thinking and imagination come into significant force in our conscious minds. Now, I have the word mythograms up there because when you look at cave paintings, in some cases, it appears as if the people who painted those painted them in temporal sequence. There will be a series of paintings which seem to be telling a story in pictures. They seem to be conveying some kind of mythic narrative. So we call them mythograms. And so we have this surface, physical surface, on which humans are telling stories, as well as on the same physical surfaces, they're doing other things like depicting animals, of showing imprints of their hands in paint, of showing abstract symbols. And so art, and we don't always emphasize it sufficiently, art was in fact a vehicle for the public visible execution of human imagination and thinking. It was a medium in which we thought, in which we imagined. And even if we want to give a lot of the importance here to language, such that we are able to, in quote, talk to ourselves and hence think, we also were evolving our artistic and craft abilities significantly, and those are also illustrative of higher conscious processes, higher cognitive processes, such as thinking and imagination. Now, I'm going to stop now for the moment, but just to throw, a monkey wrench into my own commentary here, exposition. And Dennis already was trying to throw a monkey wrench in too. I'm not being critical of you, Dennis, but yeah, it's good to throw monkey wrenches. I just happened to finish rereading, which I, on the second reading, thoroughly enjoyed, the science fiction writer Jack Williamson's classic horror story novel, Darker Than You Think. And Jack Williamson was very scientifically educated and always tried to give scientific explanations for his speculative ideas. But in Darker Than You Think, Jack Williamson presents an alternative evolutionary history of humanity in which a plausible case is made for the existence, in fact, the continued existence of werewolves and witches and vampires. And of course, there's been lots of different speculative histories of things in our distant past, things in science fiction, in fact, if not other places. H.P. Lovecraft was great at coming up with lots of bizarre visions of creatures and monsters in our distant past. But this was a very arresting novel in which we have a scientific mind giving an alternative evolutionary narrative of our history, in which he explains why there's werewolves and witches and beings that are human cousins who live among us, who have various powers and psychological capacities above and beyond Homo sapiens, um, that we would call either psychic or magical. But if you want to read a very entertaining book about an alternative view of human evolution that's to some degree different than this one and attempts to resolve some great mysteries and attempts to explain human folklore and ancient human myths and the witch hunts and Joan of Arc and everything else under the sun, I'd recommend reading Jack Williamson's Darker Than You Think. Now, I got almost 10 after 12, and I'm going to stop at this point. That's enough for today, so we can have a little discussion at the end here. And I'm going to stop sharing. Now,